This tutorial will explain how to configure NXTSD5's BACnet TCP server. Ensure you're logged in with administrator credentials and select the System menu and then select Options, which is identified by a gear icon. Within the Options dialog, use the Page button in the top right corner to change screen until the networking options are visible. On the networking screen, change to the BACnet TCP server tab to view its properties. At present, the BACnet TCP server is disabled and has a BACnet ID of 200. The server is configured to use IP port 47808, which is BAC0 in hexadecimal. Each device within NXTSD5 is also given a unique BACnet object ID. This is calculated by adding a device's Modbus address to the NXTSD5's BACnet ID. In this example, NXTSD5's BACnet ID is 200, and Boiler 1's Modbus address is 247. Therefore, Boiler 1's BACnet ID is 447. When changes are made to the server's configuration, a warning icon will appear next to the Accept Changes button. Click Accept to implement changes. NXTSD5's BACnet server is now enabled and running. NXTSD5 can generate a JSON file detailing all of the BACnet TCP server's data points. To perform this, ensure a USB disk drive is attached to the NXTSD5. The Export Tags button won't be accessible if a USB drive is not attached. Click on Export Tags once it's enabled. You will be advised when export is complete. Change to the Options Miscellaneous screen and ensure you properly eject the USB drive before removing it from NXTSD5. The created files will appear on the USB drive in a FireEye folder. The server map details all accessible data points for all devices connected to NXTSD5. You can see the BACnet object IDs of NXTSD5 and Boiler 1 here. Let's scroll down the tag list. We can see Boiler 1's off and on control is located at object ID 40380. Next, connect across the network with a BACnet client. In this example, we're using YABE. Select the Ethernet adapter to communicate through. After selection, NXTSD5 automatically identifies itself to the BACnet client. The connection is valid because we can see real-time data provided by NXTSD5. Let's query all the objects for their information. Note that the object name refers to the host device, which is Boiler 1, and the point's native Modbus address. Register 1001 in an NXF is the on and off control. Also, the BACnet object identifier is 40380, which matches the Modbus TCP server address for the same point, for consistency. Within the BACnet client, view data object 40380, which is boiler 1's off and on control. Note that enumerations are already provided. We can see that 1 is off, and 2 is on. When a new value of 1 is written, NXTSD5's BACnet server receives the command from the client and turns boiler 1 off. Let's test another point. Within the BACnet client, data object 40384 is boiler 1's manual rate. When a new value of 66 is written, NXTSD5's BACnet server receives the command from the client, and in turn changes the manual rate.